In this video, we're going to discuss dispersion of light. At this point, we've looked at refraction of light through glass, and we've looked at monochromatic light, where you have one color of light coming in, hits the normal line, bends, in this case here, when you go from air into glass, it bends towards the normal. Then when you go from glass into air, it bends away from the normal. So in the case of a prism, it bends down and down again. But now we're going to look at polychromatic light, which will disperse when it is sent through a prism. The white light comes in, and the red light, which has a wavelength of 660 nanometers, will bend less than the violet light, which has a wavelength of 410 nanometers. And then when it comes out of the prism, it'll bend again, and so this down bending and the down bending of the light, the refraction of the light, causes the light rays to separate. Here is a look at dispersion of white light. We have white light coming into this prism, and then it refracts twice, and you see the light here being separated. Red light will always have a lower index of refraction than violet light, and this is why red light bends the least, and violet light will bend the most when traveling into a new medium. So here's some examples of indices of refraction for the different colors of light. And you can see that here is listed the different wavelengths in a vacuum for different colors of light. You probably want to write these down in your notebook, the different colors of light and their wavelengths. And here are the indices of refraction of each one of these while they're traveling in crown glass. Now you don't have to write these numbers down in your notebook, but just to show that the different colors have different indices of refraction and they will each bend differently. Which now leads us into why a rainbow occurs. So you have the sunlight come in, the raindrop acts like a prism, and so the light starts to refract and separate. And the back of the raindrop actually acts as a mirror. We have total internal reflection occur, and so it bounces off the back, and then we have refraction again, and the light rays are separated. So for this to happen, you have to have the sun behind you, and then you have to have the raindrops in front of you, and the red light comes from the upper raindrops in the sky, and they come to you from that raindrop, and then the violet light comes from the lower raindrops in the sky, and then that allows you to see the rainbow. This breaking up of the light into, you have polychromatic light breaking up into monochromatic light is called dispersion, and dispersion will only occur when you have these prism shapes or these curved shapes. When you have a glass block like we've used in our lab, the light separates, but then it comes back together again. It doesn't refract twice downwards like you would with a prism.